Okay, now the picture was given. Ask it to estimate the coordinates of the intercepts and the asymptotes. What we did last time, we should understand that the light solid vertical lines are vertical asymptotes. And the dotted lines just indicate this one. And most people have that one, I mentioned. The dotted lines just indicate the X values of the intercepts, okay? Now, I'm not going to estimate yet. I'm just going to draw a curve. Okay, so there are various curves I could draw. I'm going to draw the simplest one. Got to start down here, come up through here, and then approach this vertical asymptote. We approach a vertical asymptote just the same way the reciprocal function approaches the y-axis, or the way the reciprocal square function approaches the y-axis. Okay. Now, having done this, we've got to go through this point and then approach this vertical asymptote. So we got to come down from a vertical asymptote here because we can't come up because we have no place to go through the x-axis. So we have to start up here. So we have to have a vertical asymptote that does this sort of thing. And maybe comes down here and maybe it wiggles around a little bit before it goes down here. Okay. Now those wiggles tell me this function is more complicated than the simplest one we can draw, but we're just going to do the simplest function. I don't expect you to be experts at interpreting wiggles and rational functions. Learn calculus, and even then it's kind of hard. Okay, so and then again, we've got to go through here and up here. Okay, now it's not absolutely necessary though to start down here. So I'm going to do something a little different. It'll be natural to come up here like this and just go on up. But I'm going to say, no, we come down here and we have degree 2 of 0 of multiplicity 2 at that point. Okay. So that's the way I draw the curve. Now, if you drew the curve, there are various things you could do. You could come up here and have a 0 multiplicity 2 here and come back down. Okay. Now you're compelled, you got to come down from here because there's no other way. We can't come up through here because we can't get through the x-axis. Okay, don't have a 0. So we have to go through this point and this point. And then having gone through this point, we're really compelled to approach this one down here because again, we can't turn around and go up. Okay. Well, not really though. We don't have to go through here. Again, we could come down like this and turn around here. Okay. Then we'd have a choice between doing this and just coming up from here like this. Okay. So there are at least, you know, a handful of graphs that we can draw just using zeros and asymptotes of degree 1 and 2. You might not understand what asymptotes of degree 1 and 2 are, but you will shortly. Okay, so now let's just take the function that I drew. Okay. And let's go ahead and actually everybody do this. I want you to estimate it. Just pick an x coordinate here, 1 here and 1 here. Of course, don't make this one 1 and this one 50. This is a lot closer to the y-axis than this one is. So keep it relatively to scale, okay? And you can, you know, all these vertical lines, including the asymptotes, have equations. Label them with their equations, the way you kind of locked in on the assignment from 2 weekends ago, okay? And people did real well in that as a whole. Okay, so, you know, label those lines. Gives you a deeper understanding of the graph. Somebody show me with their fingers number I ought to put on this vertical line. First set of figures I see, I'm gonna use it. Okay, 2, it's not 10. Oh man, I wish I'd have seen that 10 first. Okay, it's 2. It's actually -2. Okay. Okay, this is x equals -2. We label it right under the line. You've seen me do that 100 times, right? Get in the habit of doing it. It orients you toward what you're saying, okay? And you learn it better and faster. Also on a test, it can really help if you got all that stuff labeled and make a mistake that I can trace back to your labeling, which might be less of a penalty than looking like you don't know what you're doing at all, okay? So, be complete and really kind of get in the habit of trying to get every detail. I mean, it's important for, not just for math courses, okay? But it's real important in math courses. Okay, so let's see. What would the number be here? It'll be negative, but what do you think it would be? Somebody show me what this number ought to be. 1. I always risk getting the wrong figure when I do that. Okay, -1. Okay. So we've got a vertical line here. Now you see, I've got all these lines, right? So when you drew this picture, a lot of you left off some of the lines, especially the asymptotes. So make sure you don't do that. Okay, well, I'm going to just say this is x equals 1/2. If that's 1, that could be 1/2. Okay. And let's see, this one is about as far to the right as this one. So I'm going to say this is x equals 4, but we've also got this asymptote. And we're going to say this is x equals 3.3. Be contrary. Because that's 3.5. Any reasonable number. And you could improve on these numbers. Okay, now, second set of figures I saw was 10. So I'm going to use that for the horizontal line here. Y equals 10 on this horizontal line. Now I've got everything nicely labeled, and it becomes easier to construct a graph and especially easier to figure out what the function is. Okay, so where the numerators zeros, they're the zeros. If the numerator is 0, the whole thing is 0. The whole thing is 0 here, here, and here. At x equals -2, at x equals 1/2, and at x equals 4. Okay, so you have zeros at -2, 1/2, and 4. The degree here is 1. That's for both this one and this one because we go through the axis. Now, at least one person came down a little more steeply here and did something that was very much like a cubing function going through this one. So you would think you could have a degree 3 there. It's going to be an odd degree because it goes through the axis. The 4 is degree 2 because it's like a parabola. Okay, so I'm going to try this for the numerator. When I say try, well, you're going to have a constant out in front because when you figure out your numerator denominator and evaluate them at x equals 0, you're probably not going to get 10. So you got a constant in there, which is real easy to solve for. You got to know how to do that. You gotta know how to do that for polynomials. It's no different for rational functions. The arithmetic's just a little different, but it's just arithmetic. Okay, so denominator. Have zeros at your vertical asymptotes. Okay, where your vertical asymptotes. Your vertical asymptotes are x equals -1 and x equals 3.3. Let's emphasize that. Blue circle around this, blue circle around this, and let's even make the asymptote blue. I hate saying asymptotes, but we're going to do it anyway. Okay, so to emphasize, we need those asymptotes, and we can easily, if we're given the coordinates, and you might well be given the coordinates, okay, then you'll know what they are. But anyhow, it's going to be this. Okay, now near this asymptote, it's low on one side, high on the other, right? Well, that's the way the 1 over x function is, like this and like this. Okay, well, actually, from your point of view, it's like this, okay, and like this, right? Approaches the asymptote this way. If you have a negative coefficient, then it's going to flip and it's going to approach the asymptote this way. Okay. So I'm going to try x minus 1 times x minus 3.3. Well, this is like a reciprocal x. It could be reciprocal x cubed or x to the 5th, but the simplest is just reciprocal of x. Okay. This one, on the other hand, approaches its asymptote like this. Now, what approaches the y-axis like this? If everybody can tell me. Okay. So this isn't quite right yet, because this one approaches the asymptote on the same side, means it's got to be a reciprocal even power, and the simplest reciprocal even power is a reciprocal square. So this is degree 2, because reciprocal square is a square. I mean, you'd say degree -2, and that would make a certain amount of sense. But I just say that like a degree 2, which means you got to square the x plus 1. And this is degree 1, because this could well be a negative multiple of reciprocal square. Now, if you understand all that, everything becomes fairly simple. Okay. And that's what you really need to sort out. That's what we'll do tomorrow night on rational functions, okay? And you want to do well on that. All right, so we conclude that the function with the numbers I've got here, a reasonable estimate of this function r of x equals x plus 2 times x minus 1/2 times x minus 4 squared, because you put around at x equals 4. Okay. And the denominator is going to give you, is going to be x plus 1 squared times x minus 3.3. And I get a, I think ahead as far as I put out. I knew I was going to want to put the constant in there, and then I just wrote it without doing that. Okay, so there needs to be a constant, because if you let x equals 0, this is going to give you 16 over negative 3.3, which is about like almost -5, between -4 and -5. Well, that's not where the y-intercept is. It's at y equals 10. So this gives you negative when x equals 0. For that reason alone, it's not very good. Now, I guess that the constant is going to come out around 2.3 or something like that. We'll figure it out in a minute. Okay, so R of x is going to be some constant multiple of this. So if we graphed this function, everything would be upside down. It would look a lot the same as that, but it would be squashed down about a little over twice as much, okay? But now if we multiply by a, that's going to vertically stretch it. And if a is negative, it's going to flip it around where it ought to be. And it's going to end up looking like this. Okay. So y-intercept is 10 because we said it was. Now you might have picked different numbers, but you're just going to do with your numbers what I'm doing with mine. Y equals 10, and that equals a, which we don't know yet, but we're going to be able to figure it out. And the y-intercept occurs when x equals 0. You really need to get that deep into your brain. You need to understand that, x equals 0 everywhere on this line, just like x equals -1 everywhere on this vertical. That's why the equation is what it is. And when you write out the equations here, you're reinforcing, you understand what an equation of a vertical line or horizontal line is. You're reinforcing your understanding of that. Okay, so anyhow, it's a times 0 plus 2 times 0 minus 1/2 times 0 minus 4 squared over 0 plus 1 squared times 0 minus 3.3. And this equals, oh, wait a minute, I said this was negative. I screwed up because this is negative. Okay, a is actually going to be positive. It's going to be around 2.3 or something like that. Okay, so we get a times numerator gives us -1 times 16. Denominator gives us -3.3. I said 2.5. Yeah, it's going to be about 2.5. Okay. So a equals think, then write down the number. Don't write down the number that catches your eye. Think. Don't do myself. Okay. So a it's 3.3 over 16 times 10, right? Now, I have two negatives here, so I just discarded those and multiplied by the reciprocal. I said maybe 2.3, but don't have an estimate of 16 over 3.3. It's 2.1. Okay. So I'm still within 10%, so I'm okay with that. It's a little outside of 10% because it's really like 2.0625. That rounds off to 2.1, so I'm going to accept it. Okay, so we have this. So now And it's estimated, so there's no point in using the fraction. We can go ahead and approximate it. Because our estimates are not going to be all that accurate anyhow. The approximation doesn't hurt anything. We have 2.1 x plus 2 times x minus a half times x minus 4 quantity squared. That should have been x minus 4 over x plus 1 squared times x minus 3.3. Now you follow the same process with your own numbers. That's the process. If you're given a picture and have to estimate coordinates, you should be able to do it. Or if I just say verbally, write it out. Okay, x-intercepts are at -4, 1, and 3.3. Or 4. Okay. Sorry, x equals -2, 1/2, and 3.3. And you have vertical asymptotes at y equals -1 and y equals whatever that was, 3.3. Yeah. And your y-intercept is at y equals 10. You would then be asked to sketch the picture. And I'd like to see all the details in this picture. Okay. Then we just see what we need in the numerator to get the zeros with the right multiplicity. See what we need for the denominator to get the zeros with the right multiplicity. Again, we have a x minus 4 squared. What would the graph of x minus 4 squared look like? It would be your basic parabola with the red dot at the origin, the red dot moved over here. And that's kind of what you have close to that zero. If it gets a little lopsided there, it has to. And there's no. Now this isn't completely exactly right. I'll just say this for the good of anybody who wants to object to anything. You also, if you divide the numerator by this denominator, you have a slant asymptote. Because the denominator is going to be of degree 3, the numerator is going to be of degree 4, and when the numerator has degree 1 greater than the denominator, you can do a long division and figure out the equation of the slant asymptote. And I'm neglecting that for now because you learned to do that when you see it in homework. We did it last time. So I haven't addressed the slant asymptote. And when I did this and this, it really doesn't quite fit it. Okay. I said there's got to be a slant asymptote. It's not going to do this. It's not going to do this. It's just going to approach the asymptote as an asymptote. All right. So there's a little more to it. Now, what I want you to do is I want you to change something in the way the graph is drawn, because as I said, there are various ways you can draw this graph. You could come up here and turn around. So this could be a degree 2 zero. Okay. You could come down here and turn around. You could not turn around here, in which case you'd have to come up from here. Okay. So change at least one thing in the way the graph is drawn and sketch me a complete graph and find the function. And I'll walk around and coach you a little bit. Okay. Okay, well, we spent a little time on that. People did quite well. Be sure that your asymptotes look like asymptotes. Okay, these things are approaching the vertical line, they never touch it. So what's on one side never touches what's on the other side of an asymptote. Okay. And same thing over here, of course, these aren't gonna touch, but the thing has to keep going down. Okay, it can't come down here like this, just dive into this line and stop, okay? It acts like a reciprocal graph or reciprocal square graph in an asymptote, or maybe a reciprocal cube, or whatever. If you can do this, and everybody pretty much just did, and you know, I think everybody's arithmetic and their functions look good. Okay. I think that you are going to be able to do rational functions just fine. Okay. Doesn't mean you're going to do them perfectly, because there's some challenging questions. But if you can look at a graph, figure out what the factors of the numerator ought to be, what the factors of the denominator ought to be with the appropriate multiplicity, which is based on understanding what a squaring function looks like or what a linear function looks like. Okay. Or reciprocal square. Then I think you're going to be in good shape. Let's do one more just for practice. Are you gonna look over recording? Okay.